Hi everyone, I'm Rookie. Welcome to Mathkey. In today's video, I'm going to show you how to multiply like terms. What are like terms? Like terms are simply the terms that carry the same variable. For example, the term 5y and 8y are both like terms because they carry the same variable y. However, the term 12h and 9d are unlike terms because they do not carry the same variable. Now, looking at these two like terms, if we were to join them together, I'm going to show you how to multiply them. I'm also going to show you how to multiply terms that carry exponent. For example, the term 3t raised to power 5, 4t raised to power 2, and 7t raised to power 4 are all terms with exponent because the variables carry power. Now, if we are to put the terms together, I'm going to show you how to multiply them. Before we start, I'm going to show you some simple rules of multiplication of operations. Now, we're going to bear in mind the following. Whenever a negative number multiplies a negative number, the result must be positive. And when a positive number multiplies a positive number, the result must also be positive. However, when a negative number multiplies a positive number, the result must be negative. And when a positive number multiplies a negative number, the result must be negative. Now, if you check the first two multiplications, you will see that the first operation and the second operation of the first one, they are the same. So the result is positive. Similarly, if you check the other one, the first operation and the second operation are the same. So the result is positive. So when an operation multiplies itself twice, or 4 times, or 6 times, or 8 times, the result must be positive. Now, checking the last two multiplications, you will see that one of the operations is negative and the other is positive, but the result is negative. Similarly, the first operation of the last one is positive and the second is negative, and the result is negative. So when two operations are being multiplied in such a way that one of them is negative, then the result must be negative. Now, I'm going to show you some other rules that you're going to bear in mind. When multiplying algebraic terms, like terms to say, the operations must multiply operations. Then the numbers will multiply numbers and the letters will multiply letters.
There is what is called laws of exponents. In this video, I'm going to show you the first law of exponents. Now, this law states that when numbers or letters are multiplied repeatedly, we'll take one of the bases, add up the entire exponents, and assign the sum to that base. For example, if we have the expression x raised to the power of 3 times x raised to the power of 2 times x raised to the power of 5, the law is saying here that we'll take one of the bases, then add up the entire exponent, then assign the sum to that single base. Take note that the base here are the numbers under, while the numbers on top are called the exponents or the powers. Now, the first thing we're going to do here is to keep our equality symbol. The law states that we'll take one of the bases, take the entire exponents, and add them up. So in the end, everything becomes x raised to the power of 10. So x raised to the power of 3 times x raised to the power of 2 times x raised to the power of 5 is equal to x raised to the power of 10. And that's according to the first law of exponents. Similarly, we can have d raised to the power of 2 times d raised to the power of 5. In the end, everything becomes d raised to the power of 8. Any question?
Yes, sir. I have a question. 2 plus 5 is 7 and not 8. I think you have just made a mistake. You're meant to have d raised to the power of 7 and not d raised to the power of 8. And that's because we have only two exponents, 2 and 5. So 2 plus 5 is 7 and not 8.
Oh yes, and that's because the d in the middle has an invisible power of 1. Now in mathematics, whenever a letter or a number is written without any power, by default, technically, it means that that letter or that number has an invisible power of 1. For instance, we can have the letter y. This y you see here without the power technically has an invisible power of 1. So we can rewrite this as y to the first power. Remember I told you earlier that this law of exponents also applies to number. So if we have the number 3 raised to power 2 times 3 raised to power 4 times 3, in the end everything becomes 3 raised to the power of 7 according to the law of exponents. That's the first law. Now remember also that the last 3 you see here has an invisible power of 1. So everything sums up to be 7. So what we're saying is that 3 raised to power 2 times 3 raised to power 4 times 3 raised to power 1 equals to 3 raised to the power of 7. Now that we are fully prepared, let us see some examples. Supposing we have 4r raised to the power of 3 times 5r raised to the power of 4. This is a question we're going to solve, and it's easy. Okay, remember the rules I give to you. Operations will have to multiply operations, number will multiply numbers, and of course letters will have to multiply letters. Now if you check the first term, 4r raised to the power of 3, it looks like it doesn't have an operation right at the front. And so also is the second term, 5r raised to the power of 4. Both of them have a positive operations that are invisible. Okay, so plus times plus is plus. So we're just going to neglect the operations and go straight to the multiplication. Now the first thing we'll have here is that the number 4 will multiply the number 5, and that's exactly 20. Okay, and the letters will multiply themselves. So r raised to the power of 3 multiplies r raised to the power of 4, and that's r raised to the power of 7. So everything is 20r raised to the power of 7. Now let's see another example. Suppose we have negative 7m cubed times 6m. Okay, the first term has a negative operation, and it looks like the second term, 6m, doesn't even have an operation. There is an operation there which is invisible. So what we'll do is I will shift the 6m and introduce the positive operation, which is invisible. And the next thing is for us to group the first term and group the second term. So we'll just go straight to our multiplication. Operations multiply operations, numbers multiply numbers, and of course, letters will have to multiply letters. Now let's get started. A negative operation multiplies the positive here, and that's exactly a negative result. So minus times plus is minus. Okay. The next is the number 7. So 7 times 6, that's exactly 42, right? And m raised to the power of 3 multiplies m. Take note that the m in 6m, the m has an invisible power of 1. So m cubed times m raised to the power of 1 is m raised to the power of 4. All right? So let's see the last example for today. If we have negative u multiplying negative 3u raised to the power of 4 times 8u squared, okay? Okay, this is still very easy, and okay, if you check the first term, negative u, it looks like it doesn't have a coefficient, and it looks like it doesn't even have an exponent as well. Okay, remember I told you when a letter or a number is written alone without any coefficient, it has an invisible coefficient of 1. So what we are going to do here is just to introduce that invisible coefficient of 1 in front of the letter or the variable u. Okay, and similarly, the u has an invisible exponent of 1. That's what we also said. When a letter or a number is written without any power by default, technically has an invisible power or exponent of 1. Okay, so we've just introduced the 1 as an exponent to the letter u. Okay, the next is the second term, that's negative 3u raised to the power of 4. It has a negative operation, and the last term, 8u squared, it looks like it doesn't have an operation, so we'll just shift it and introduce the positive operation. Okay, so we'll just group each of the terms. We'll group the first term, we'll group the second term, and we'll group the third term. Now let's go straight to our multiplication. The first operation, which is the negative, multiplies the negative operation of the second term, and that's a positive operation. So the positive multiplies the positive of the third term, and that's a plus sign. Okay, so minus times plus is plus. The next is the 1, the 3, and the 8 that will multiply themselves. So 1 times 3 is 3, and 3 times 8 is simply 24. Okay, so we're done multiplying the numbers, and the last here are the letters. Okay, u raised to the power of 1 multiplies u raised to the power of 4, and that's exactly u raised to the power of 5.
And u raised to the power of 5 multiplies u raised to the power of 2. And that gives us exactly u raised to the power of 7. All right. And everything becomes 24 u raised to the power of 7 without the positive operation. Remember, we can write everything without the operation. Thanks for watching. You've just learned that to multiply like terms, operations will multiply operations, the numbers will multiply the numbers, and of course the letters will have to multiply the letters. We've also learned that a letter or a number without a power has a constant power of 1, and a letter or a number without a coefficient has an invisible coefficient of 1 as well. And we also learned that when a letter or a number is written without an operation, by default, technically, it has an invisible positive operation. Thanks for watching. If you want to see more of these videos, subscribe to our YouTube channel. See you in our next video. Bye.